My dear students, in this video on the continuation of the topic differential equations, I am going to introduce the applications of differential equations, application problems involving differential equations. These application problems you can find in both CBSE and State board syllabus. Application problems are very important problems to our day-to-day life. For example, consider this problem. In a bank, the principal increases at the rate of R% per year. A person deposits an amount in a bank. That bank gives a rate R% interest per year. Principal increases. Find the value of R, the percentage R, if rupees 100 doubled itself in 10 years. The amount deposited doubled in 10 years. If it is so, what is the rate of interest? That is the problem. See, the rate of interest, suppose let the principal be, let the principal deposited in the bank be P rupees, say. Let the principal be P rupees, say. So principal increases at the rate of, so principal increases, increasing rate is dP by dt. Principal increases at the rate of the time t in R%, that is R by 100 of the principal. The principal is increases at the rate of R by 100, R%, that means R by 100. This is the required differential equation. And we have to find out the rate of interest R if the amount deposited is 100 will double in 10 years. Initially the amount is 100 rupees, after 10 years it is doubled. If it is so, what is the rate of interest? We have to find. So from this expression I am rewriting this as dP by P equal to R by 100 into dt. Now integrating both sides. This is dP by P is log P. Now you take the constant R by 100 out of the integral dt. This is integral dP by P is log P. Once again you write this is dP by P only. Now you integrate both sides. This is log P equal to R by 100 into integral of t is dt is t plus an integrating constant c. Now exponentiation, raising the power of e power log p is p. E power log p equal to e power R by 100 t plus c. So e power log is p. It is p equal to e power R by 100 into t into e power c, because e power R by 100 plus c is e power R by 100 into t into e power c by a power m into a power n rule. You split this addition into e power R by 100 t into e power c. Now initially at time t equal to 0, the principal is 100 given. Initially time is 0 and the principal value is 100. E by e power R by 100 into t is 0 into e power c. This is our first condition. This is our first condition. R by 100 into 0 is e power 0, e power 0, 1 into e power c is e power c is 100. Now you replace e power c in the equation 1. Instead of e power c, you substitute 100. Therefore, from 1, p equal to e power R by 100 into t into e power c is 100. This is our equation. Now, after 10 years, what is after 10 years? The amount p is doubled. That is 200. The amount p is doubled. 100 into 200. If it is the case, t is 100, 10, p is 200. So t equal to 10. So therefore, this equation becomes P is 200. After 10 years, the principal value is 200 equal to e power. We have to find out R by 100 into T is 10 years. Into already the 100 is there. Now 200, you bring this 100 to the left hand side, it is 200 by 100 equal to e power 1 over R by 10. 10 by 100 is R by 10. So this is 2 equal to e power R by 10. So, sorry, R by 10. 1 by 10 into R or e power R by 10. So we have to find out R from this expression, taking logarithm on both sides. Taking logarithm on both sides. This is an application problem. Finding the rate of interest. The amount deposited is doubled after 10 years. Therefore, taking logarithm log 2 equal to log of e power R by 10. Log 2 is given in your problem. 0.6931 equal to log e R by 10 into log e is 1. R by 10 into log e is 1. Okay, now R equal to 0.6931 into 10. That is 0.6931 into 10 is 6.93 equal to R. So our required rate of interest is R equal to 6.93%. So if the rate of interest is 6.93, then the amount is doubled after 10 years. That is the problem. This is an answer for the problem. R should be 6.93. Then the amount 100 should becomes 200 after 10 years. So this is our required answer. Okay. Next problem. The same application problem. It is in the CBSE textbook also. You can find the problem. Now, in a bank, the principal increases at the rate of 5% per year. In this problem, the rate given. In a bank, the principal increases at the rate of 5% per year. The required question is, an amount of rupees 1000 is deposited with this bank. How much will it worth after 10 years? This is a problem. An amount of rupees 1000. The problem is, in a bank, principal increases at the rate of 5% per year. An amount 1000 is deposited in a bank now. An amount rupees 1000 is deposited. The question is, how much will it worth after 10 years? How much will it worth after 10 years? Or how much will the person get after 10 years? How much will it worth after 10 years? That is the problem. Here also one value log e power 0.5 is 1 point. Here one data is given. e power 0.5 equal to 1.648. That is the problem. So in this case also, in the previous problem, the matured amount given, that is the amount is doubled, and what is the rate of interest? That is the question I asked in the previous problem. Now in this problem, a rate of interest is given, amount deposit is also given, how much it will earn after 10 years if the rate of interest is 5%. So how much amount will you get after 10 years is the problem. Here also the differential equation is amount is P, so dP by dt, principal amount is P, consider dP by dt equal to 5 by 100, rate of interest is 500 given into P, amount P, rate of interest is 5. Now from this expression, dP by P equal to 5 by 100 into dt. So dP by P equal to 5 by 100 dt. Now integrating both sides, log P equal to 5 by 100 into integral t dt is t plus c. So raising the power as in the case of previous problem, e power log p is e power log p. E power log p equal to e power 5 by 100 t plus c. 5 by 100 you can write it as 1 by 20. E power log is 1. So p equal to e power log, cancel reciprocal functions. E power 5 by 100 is 1 by 20 t plus c. So in this case, initial amount is 1000 at the time t equal to 0. When t equal to 0, initially the amount p is 1000 given. Therefore, this equation 1 becomes p is 1000. 1000 equal to e power 1 by 20 into t is 0 plus e power 0 is 1. Therefore, c equal to 1000. So you get the value of c. C, this is 1, e power 0 is 1, c equal to 1000. You replace the equation 1. Instead of c equal to 1000, you will get so from 1 p equal to e power 1 by 20 into t plus c is e power 1 by 20 into e power c, is it not? E power 1 by 20 into e power c. So this is e power 1 by 20 is e power 0, 1. This is e power c. So e power c is 1000. Alright, you correct it? E power c. E power c is 1000. So this is e power 1 by 20 into t into e power c. E power c is 1000. Now, what is P, principal value P, after 10 years? What is the worth of the 1000 in the deposit amount 1000 after 10 years? That is the question. Therefore, P we have to find out. E power 1 by 20 into t is 10 years into 1000. That is equal to e power 10 by 20, e power 1 by 2. Into 1000. e power 1 by 2 is e power 0.5, I mean. E power 1 by 2 p equal to e power 1 by 2, you can write it as 0.5. 0.5. E power 0.5 is given as 1.648 into 1000. This is multiplied by 1000, you will get 1648 rupees. So this is your PP. So after 10 years, the 1000 is increased by 1648. So after 10 years, the principal P equal to rupees 1648. That is your answer. That's all about the problem. This is the increasing amount is 1000 to 1648. 648 is gain. So next, one more problem in the application problem. We will see third one. So like that in your day-to-day life, in the amount deposited in a bank, we have to find out the rate of interest. We have found rate of interest in the first problem. In the second, we determine the amount we received after 10 years. So these are, and the third one is, find the equation of the curve whose slope is, find the equation of the curve. Find the equation of the curve whose slope is y minus 1 by x square plus x. Whose slope is y minus 1 by x square plus x. It passes through the point 1, 0. That curve passes through the point 1, 0. If the curve passes through the point 1, 0 and its slope is y minus 1 by x square plus x, then what is its equation? That is the problem. Slope is, you know, slope of a curve is nothing but dy by dx. It is given by y minus 1 by x square plus x. Slope always given by dy by dx. Derivative of the curve, first derivative is called slope, which is given by y minus 1 by x square plus x in the problem. From this, dy by y minus 1 equal to dx by x square plus x. So I can rewrite this dx by x square plus x. If I take common as x term, I will get x square, x I can take x plus 1, x square and x plus 1. Here dy by y minus 1 on the right hand side. Therefore, dy by y minus 1 on the right hand side. So now integrating dy by y minus 1 equal to split this into two integrals. Integral 1 by x dx it is integration by parts, you have to say, right? You consider this integral, or right hand side integral, you consider 1 by x into x plus 1 by, you split into partial fractions, a by x plus b by x plus 1. Like that you have to split. Now, cross multiplying numerator 1 equal to a into x plus 1 by the principle of partial fraction plus b into x. Now, using unknowns a and b, you have to determine if x equal to 0, 1 equal to a, into 1 plus b into 0, 0. Because x equal to 0 into 0. So a equal to 1. Similarly, if you put x equal to minus 1, you will find if x equal to minus 1, 1 equal to a into 0 plus b into minus 1. So minus 1 into b is minus b. So b equal to minus 1. So like that we have determined. Now b equal to minus 1. If you put x equal to minus 1, the left hand side is 1 equal to a into minus 1 plus 1 is 0, b into minus 1 minus b, so b is minus 1. A and b you determined, you now split this into integral, left hand side integral, as usual dy by y minus 1. Now, integrating both sides, left hand side is integral dy by y minus 1 is equal to integral a by x. A is 1 by x dx minus b is minus 1, therefore minus 1 minus outside will get 1 by x plus 1 dx. So now by integration formula, integral y by 1 by y minus 1 is log y minus 1 equal to integral 1 by x is log x minus integral 1 by x plus 1 is log x plus 1 plus log c. Integrating constant also you can consider by log c. So this is log m plus log n, log cx. Numerator is cx by x plus 1. This is log c into x by x plus 1. Here you get log of y minus 1. Now eliminating logarithm, you will get y minus 1 equal to cx by x plus 1. Now the condition is the point curve passes through the point 1 comma 0. Now you substitute x equal to 1 and y equal to 0, you will get the unknown c, and thereby you will get the answer. Equation. You consider this as expression by 1, equation 1. In this equation 1, put x equal to 1. In the equation 1, replace x equal to 1, y equal to 0. Y equal to 0, you get minus 1 on the left hand side. This is x equal to 1 is 1 into c. C by 1 plus 1 is 2. So c equal to minus 2. By cross multiplying, c equal to minus 2. So substituting in this equation 1, therefore the equation of the curve is y minus 1 equal to c minus 2x by x plus 1. Now you simplify, y equal to minus 2x by x plus 1. This minus 1, if you bring it to the right hand side, it is plus 1. This is the required equation, and you simplify, you will get the answer. That is y equal to therefore the equation of the curve, required equation of the curve. Therefore the required equation of the curve is y equal to, taking x plus 1 as common LCM on the right hand side, minus 2x plus 1 into x plus 1 is x plus 1, minus x plus minus 2x plus x minus x, that is 1 minus x by x plus 1. Y equal to 1 minus x by x plus 1 is the required equation of the curve. That's all about the problem. This is the answer for the required curve. Now, this is y equal to 1 minus x by x plus 1, which is the required equation of the curve. Okay, that's all about the problem. I will stop here and we will continue in the next video. Thank you.